Hey folks, Ms. Gosling here. In this video, you're going to learn about fields. By the end of the video, you'll be able to describe gravitational and electric fields. So let's go ahead and get started. I want to start with just a quick definition of what a field is. A field is, in fact, not something where you plant vegetables or play baseball. Instead, what we're talking about when we talk about fields are regions in which particles with the necessary characteristics feel a force. So what that means is if a particle has the necessary characteristics to feel a gravitational force, then anytime it's in a gravitational field, it's going to feel that force. So initially, when we talked about forces, what we talked about were things like the applied force, friction, tension, and the normal force, all of which require a physical connection between the object that has a force acting on it and the object enacting the force. So for example, if I am trying to push a cart, unless I'm touching that cart, the cart is not going to feel the effects of my applied force. However, gravity is different, right? I don't have to be physically touching the earth to feel gravity. In fact, if I throw a ball up into the air, that ball is inevitably going to fall back down because it feels gravity. This contrast is an example is really that contrast between a force that occurs due to a field, such as gravity, and our contact forces. So in this unit, we are going to be focusing on our forces that are caused by fields, specifically gravity and electricity, with some brief discussions of magnetism, but again, we'll be focusing on gravity and electricity, and we'll be talking about magnetism primarily next year. So let's go ahead and start by talking about gravity. So gravitational fields are generated by masses, and only objects with mass feel gravity. And on Earth, little g, 9.8 meters per second squared, is actually the gravitational field on Earth. So when I put an object with a given mass into my gravitational field on Earth, little g equals 9.8, that mass is going to feel a force due to the gravitational field. And every mass should feel the same effect of the force. So you'll notice, right, the gravitational force on you is 9.8 times your mass. The gravitational force on me is 9.8 times my mass. And you'll see this as a pattern throughout our discussion of gravity. So electricity is a field that you might be a little less familiar with. So electricity is a field that is generated by charges rather than masses. So when I say charges, I mean objects that either have a positive charge or a negative charge. So a good example of something that's charged is an electron, which has a charge of negative charge. And because these electrical fields are generated by charges, only charged objects are going to experience electricity. So what that means is if I have an electrical field due to an electron, or some other thing, so let's say this is my electrical field, and I throw an object with a charge of 0 in that field, that object will not feel a force. However, if I put in a positively or negatively charged object, those objects will feel forces in opposite directions. Now, as I mentioned, there are two kinds of charge. We have positive charges and negative charges, and this is a big difference between electricity and gravity, right? So in gravity, something has a mass or it doesn't. You don't have something with negative mass, as far as we're aware. There's some theoretical particles that might have negative mass, but we have no way of, at this point, of really detecting them. So at this point, that's really just theory. Electricity, on the other hand, we know there are positive and negative charges. We know that there are protons and electrons. We know that there are up quarks and down quarks. And so because of that, the rules for electricity are a little different than the rules for gravity. So in gravity, one mass attracts another, right? So you and your mass are attracted to the earth, which is why you would fall down. if you were to jump on a trampoline. Similarly, the Earth and the Sun both have mass and they are attracted to one another, which is why the Earth rotates around the Sun. In electricity, we have to worry about whether we're looking at two like charges or two unlike charges, because like charges repel and opposite charges attract. So what that means is if I take a positive charge and I put it next to another positive charge, they're going to move away from one another. However, if I was to take my second positive charge and replace it with a negative charge, what I would find is that instead of being repelled by one another, my positive charge and negative charge will move towards each other, like so. So that's really the basics of electricity and gravity, are two major fields. And so let's go ahead and go through some takeaways. So first of all, fields occur due to non-contact forces. And there are exactly 4 non-contact forces that we are aware of. The first 2 we've talked about, gravity and electricity, which here you can see I've written as electromagnetism because, as you will learn later, electricity and magnetism are deeply entwined with one another. There are also, in addition to gravity and electromagnetism, there are also 2 nuclear forces, the strong and the weak nuclear force. And again, we're not going to be talking about that in IB Physics 1. In IB Physics 2, however, we're going to cover what the strong and weak nuclear forces are, act upon, how they act, the distance over which they act, and so on. So gravitational fields and forces affect only objects with mass, and electrical fields and forces only affect objects that are charged. So if I put a massless object like a photon into a gravitational field, it theoretically, in this classical model of our forces, will not feel that force. We actually know now in modern physics that photons do actually bend around gravitational fields, but for the sake of this class, we're not going to be worrying about that. Similarly, if I take a neutral object and I stick it in an electrical field, so for example, if I take you, who's neutrally charged, and stick you in an electric field, you are likely not going to feel any force, just because you are a neutral object. Now, if you have any charged particles inside you, those charged particles will, of course, feel that force. So this has been your quick introduction to fields. Throughout the rest of this unit, we'll be mathematically exploring gravity and electricity. We'll be comparing them and contrasting them, and talking about some of the ways that we can use them to better understand the world around us. So with that, it's your turn to try solving some field and force problems. Best of luck and happy solving.